Okay, choose a graph of the function below that doesn't have a domain of all real numbers. So left to right is your domain, left to right. Okay, so left to right, I'm looking for negative to positive. That means it points forever to the left and points forever to the right. Well, this guy points forever left and forever right. That one's gone. This one points forever left and forever right. That one's gone. It has to be C. But I'll show you here. I'll put a big line right here. This tells me that it stops, like it's interrupted here. Okay, that line, that little piece right here is where it starts. So that's why it's this guy. Because it's not forever to the left. It's only forever to the right if you look here. I can even put a little note, not forever to the left. It is to the right, but not to the left. Right? That's how you know that. The next one, given the graph, identify the domain. So now we're kind of applying what we just talked about to this next problem. Left to right is negative infinity to positive, but if you look right here is where I start, that big dot. And that's at what number? Negative 2. So I'm going to go negative 2 to positive infinity, and I'm done. That's my answer. Okay? So in yellow here, negative 2, and it stops or keeps going on forever here. See how I didn't even touch this negative infinity sign? Okay, that's why. It doesn't go forever to the left. Okay? Sketch the graph that represents a function with an odd degree and a negative leading coefficient. Okay. So I'm going to show you, I'm going to sketch a graph, and I'm going to sketch the graph of the rest of them too. So an odd degree with a negative leading coefficient. Odd degree means opposite arrows, if you remember from way back when. Opposite arrows or ends, whatever one you prefer. It just depends on what term you like. Okay, this one, a negative leading coefficient. That means that the right arrow or the the right arrow ends down. Okay, so it's ending going down. So just kind of being more specific with you of like what you're looking for. So using those two things, what's really nice about multiple choice though is that like you're given multiple choice. So you wouldn't have to like come up with it on the top of your head. You're going to be given it, you're going to say, okay, which one is it? So it's going to end going down, like we said. And because it's opposite arrows, where are we going to start? Are we going to start going down 2 or are we going to start going up? If it's opposite arrows. Up. So it's going to be like this. And you can just sketch it. It doesn't have to be perfect. And you're done. Okay, that's opposite arrows. And it ends going down. You could have even drawn something like this. And I'd be happy. As long as it looks like it's opposite and ending going down. Okay? When you get to number 6 on your packet, I'm going to go over something together with you before you start. Because I can ask you anything. I can ask you even positive. I can ask you odd negative. And I'll kind of write them all out for you so that you know. Okay, this one. Determine the following polynomials have an absolute or relative max or min. So odd degree polynomials go forever up and forever down. Okay? So if that's the case, then you're not going to have absolute maxes or min. Okay? So these two will be relative. You won't even have an absolute max or min. So I'm going to put off to the side for odd. It will never have absolute max min. Okay, can't. If it goes forever up and forever down, there's just no way. Can't have that. And then I'm also going to draw out what they look like because this is actually going to help you on number 6 as well of the yellow packet. Okay, so an odd degree with a negative leading coefficient, that's what we just did. So it looks like this. I'm going to kind of sketch it out for you so that you can kind of look at the graph. Where the opposite is going to look like this because it's going to end going up because it's positive going up. like this. So if you see a graph that looks like that, then that's an odd degree but positive. Now let's take a look at even degree and even degrees. They're going to have absolute maxes or min. So absolute, let's talk about this. If it's even degree, we have the same arrows. But if it's negative, are we going to be pointing both up or both down? Both up or both down if it's negative? Down. Is that going to be a max or a min? A max. Very good. Okay. This one, please change to positive. I need to make a note for next year that it was supposed to say positive here. And if it's positive, they're going to be both facing up like this. So would it be an absolute max or a min? An absolute min. Very good. Okay, so I just kind of listed them all out there for you. Obviously, you don't have to memorize that, but I wanted to make sure that you knew them all. Okay? Odd degree negative looks like this. Odd degree positive looks like this. Even negative, they're both pointing down and it has an absolute max. Even and positive is pointing up and it has a min. Okay? Questions? Okay, cool. And I'm actually going to put number 6 right here because it could help you there too. It actually probably will help you a little bit more that I drew those out for you. Okay, so this one, given a function, we want to write it with the transformations here. So transformations is probably one of the biggest topics that we did in this semester. We did it in like 3 different chapters here. So I'm going to go over them a little bit. I'm going to write out the general formula. F of x is equal to a, x minus h, to some number, it doesn't matter what number it is, plus k. And this is where we went like left, right, up, down, we stretched, we compressed. Okay, so this negative, when it reflects over the x-axis, is going to go right here with the a. So I know I'm going to put a negative right there. I'm just going to rewrite this part out. Okay, the x is always going to stay. And then it says translated 2 units to the right. Okay, when I go right something, is that positive or negative? It's positive. So when I plug into my formula, I'm going to plug in a positive 2. Again, if you look, that's kind of why that's always the opposite sign. Because look, in my formula, it is negative. I'm plugging in a positive 2. That's why it looks like it's the opposite here. Then I have to the 3rd power. Okay, then this piece right here, 4 units up. So I'm just going to add 4, and we're done. Now, obviously, that was weird and probably super hard and confusing or if you didn't remember it, but you're going to be given multiple choice. So you're going to be able to be like, oh, that one's it. But it's hard sometimes to come up with it on your own. Okay? Multiple choice will be 10 times easier here. Flip when you're ready. Okay? I know, bear with me. Probably your brains are going to be hurting this whole week and a half, but push through it because you won't have to study at home mostly for math. Identify the transformation. So now we're reversing it. I give you a function. You tell me the transformations. Is this 1/2 going to be stretching or compressing? Stretching or compressing? It is compressing. So compress. Ooh, sorry guys. It's like lagging. Hold on. Compress by 1/2. Okay, and then this guy, this plus 3, would I be moving left or right? Careful. Left. Left. 3. And then we got the last guy. This -5 means up or down. Down. 5. Done. Okay? And like I said, on multiple choice, it's so much easier because when you have to come up with this stuff on your own, it can be challenging. But like to see your answer choices makes it so much easier in my opinion. Not saying it's really easy, but it will make it a little bit easier. Okay? All right, this one, factor by grouping. You guys got so good at this, and I hope that you didn't lose this skill because I think it's super essential. Factor by grouping. You have 4 terms here. do exactly what it says. Grouping means parentheses, to remember. Grouping means parentheses. So I'm going to group the first two, and then I'm going to group the second two. What number and letter can come out of the first group? Very good. So I'm going to put a 5x right here, and whatever's left is going to go inside. And maybe kind of just, again, for the sake of notes, you don't have to put all this in when you're doing your work, but you're dividing by the GCF. So I'm going to divide by 5x and divide by 5x. Whatever your GCF is, it comes out on the outside. So I'm left with x plus 2. Very good. Questions? Okay, the next group. What's common between those two? What's the GCF? Very good, a 6. So I take out a 6 and divide each one by that GCF. And what's left inside? Very good, x plus 2. And now if you remember, you guys really liked this part of the problem because now one of them's the same, which is really nice. Go ahead, Jamil. You can.
Parentheses, 5x plus 6 plus parentheses, parentheses, x plus 2 plus parentheses.
Very good. That's your final answer. Good job. Okay. Do you have any questions on that one? That I feel like you guys got like so much better at that as time went through the semester here. Okay. We're already almost there. This next one, it seems like I must have accidentally deleted the graph. Okay. I said given the graph, between which x values does the function increase? Okay, so I'm just going to make up a graph to make sure that you have something here. I'm just going to make up a random graph. It's not coming from anywhere but my brain. Just making it up completely right now so that you have something. I'm going to do something like, let's say this. And just kind of draw a W, like somewhere around that way here. And I'm going to give you some points here. I'm going to put 1, and then a 3, and then a 5. So that you know that those are your x values here. Okay? So I just totally made up a completely random graph to make sure that you had an example to look off of when you're doing your yellow packet. Okay? So I know that this value is 1, that one's 3, and that's 5. That's your x values. It says, when is a function increasing? So I'm looking from left to right when it's increasing. So I'm going to put my finger all the way to the left. Decreasing, then it starts to increase right there. So I'm going to increase from -1 all the way to +3, if you notice that. From this piece all the way to that piece, I increased. So I have 1, 3, and then let's find the other piece because there will be another piece here. So 3 to 5, you see how it's decreasing? So then from 5 to where am I going to increase? Yeah, 5 to infinity. So from 5 all the way up. So 5 to infinity. We're done. Again, made that graph up, so if you're like trying to figure out where the graph came from, it just came from my brain. Because it looks like I deleted it on accident. Okay? So really you're just talking about from this piece to this piece in blue, and then from this piece to this piece right here. Okay? All right. Now this one, it says, describe the end behavior using limit statements. Well, it's hard to describe the ends of a graph when you don't have a graph. So we got to get out a graphing calculator when this happens. So let's get out a graphing calculator, and we got to type it in. Go to y equals like normal. If my calculator would pop up for me. You probably can type it in a lot faster than I can because mine's just taking a little bit of time here. All right. Go to y equals, I type it in, and then you should get that graph. Did you get that graph when you typed it in? Awesome. Okay, so I'm just going to go on my notes, and I'm just going to sketch it so that when you go back and you look at it, you know what you're talking about. So it looks something like this. Doesn't have to be perfect, but it looks something along those lines. The most important thing is that you have the arrows in because you want to know where your ends go because it's the end behavior. So I'm going to come back. So end behavior, I'm gonna like box this or highlight it or something. Your end behavior are your ends. They're your ends. Okay, your arrows. So this guy, negative infinity is your left side. Where's that arrow going? To positive or negative infinity? Yeah, negative infinity. So I'm going to write that out on my graph. And then in green, where is this end going? To positive infinity. And we're done. So maybe make a note that this is going to be your left arrow. And this is going to be your right arrow, if that helps you. Remember? Your left arrow and your right. Because this is your negative side and that's your positive side. Okay? And last one, which I think is pretty easy because we practiced this one kind of already. Write a function that represents the following graph. Okay? So we want to use our x-intercepts here. What are my x-intercepts? There's 3 of them. Very good. So I'm going to use all 3 of those to write a function. Remember yesterday we learned about it being like x minus something, x minus something, x minus something. Just got to plug them in. So I'm going to plug each one in here. So in blue, I'm going to plug this guy in. When I plug in a -1, it's going to change my sign. Because when you plug in 1, it changes the sign. That's why when I always say, hey, it's opposite signs, that's why. I just kind of proved it to you. When you plug it into the formula, it changes the sign. Okay? Here, this 1's going to go in. It's not going to change anything. I'm just going to plug it in. So 1. I'm going to take this 3, plug it in. Put it there, and we're done. So here, really the biggest thing is that it's always going to be your opposite signs. That's what we learned yesterday, too. We kind of went over that. It's always your opposite signs. Cool? Okay, you have like more than half a period. You have like 30 minutes. But before you do anything, make sure number 6 kind of makes sense. I would definitely go back to this one and put 6 here because I think this one's going to help you more because I drew the graphs for you. Okay? The rest of the time is yours. You can check your answers. You can relax, whatever you need to do. I'm not going to be checking this in until the day of the final, but you want to make sure you're studying. Okay. What did you say? You said you were